All right, we're live.
Sweet.
One of these days, we're going to get this figured out.
Oh, you.
Seriously.
All right.
Ready to. I'm on question 3, so
Yep.
ready to roll. Oh, there's 13. Sucks. Okay, let's go. I'll start. While you were required to work. Let's get that information. Use the following to answer the next 3 problems. Human blood can be classified into one of our basic types: O, A, B, and AB. The proportion of people in the population of the United States with each of these blood types is summarized in the following table.
So that's a percentage then?
Yep. The blood types and the proportions given in the table above define a probability distribution. I would say that's true. Unless there's something I'm missing.
I think I agree with that.
Yeah. Because all those numbers should add up to 1.
Yeah, they do. I did that.
And they're all more than 0 and less than 1. And none of them are negative, so they follow the 3 rules.
Yep.
I see.
Okay, so number 4 says, what is the probability that a randomly selected person in the United States has type O blood, rounded 2 decimal places?
That'll be 0.45, right?
Yeah, that's what I would think it is right off the bat, yeah.
So what is the probability that a random person selected to have type O blood? 0.11.
Oh, sorry. Type O. No, type O blood is 0.45.
Oh. Not have type O blood. So I screwed up there.
We're on question 4 still?
Question 4 is what's the probability that the person has type O blood?
Correct, and so it should be 0.45.
Correct. And so the probability number 5 is that the person will not have type O blood. That should be the rest, so it should be a 55% chance.
Correct. Yeah, I agree with that.
0.55. All right. Next.
All right, use the following information to answer the next 2 questions. Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 of the samples came from a person identified as a bladder cancer patient. Question 6. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer patient? Round to the nearest 3 decimals.
That's going to be 1 divided by 6.
1 divided by 7, right?
That's what I was good.
If there's only 6 poles, it should be 1 divided by 6.
Now there were 7 bowls containing urine.
Yeah, 7
Six.
bowls containing urine. 6 of them were regular patients. and
Oh,
then
okay,
one
yeah,
was-
okay. 1 divided by 7, you're right.
Yeah, I had to go back and reread that too.
So I've got
14.286.
Well, it says to the 3 decimal places, so I got a 14, so 0.143.
Yeah, are we around? I think we're so. I don't think we're doing percent. I'm doing decimal places or decimal.
Right,
So
and I think that's what we're
question-
supposed to do.
In question 4, I've got 0.45. Question 5, 0.55. So question 6, I would put 0.143.
That's what I have. I haven't been putting the 0, just point, but yeah, that's what I've been doing.
Okay.
Yeah, so I got 0.143 for that.
Yeah, that's what I have as well.
Yeah, I just put it in a percentage, so that's what I have.
Okay. Excellent. Question 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that the dogs would do this well by random choice alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There is little evidence that dogs could detect it. So I'm going to do, what did it say, 22?
Divided by 50, what?
54.
So they're selecting it 40% of the time, where if it was just random, it would be 14% of the time. So I would say strong evidence that dogs can detect it. What do you guys think?
So if they're correct less than half the time, there's strong evidence they can detect it.
Yeah, because if they're choosing randomly,
Mhm.
they would be more likely to be closer to 14%, but they're choosing it 40% of the time.
So is 14% kind of the threshold?
Yeah,
Well, if
14,
you were guessing, you'd get it right 14% of the time.
right. So there's a good chance they're not just guessing. They have an idea of which urine has bladder cancer because they're guessing it, or they're getting it 40% of the time instead of 14% of the time.
I get it, and you're getting the 14% from the previous answer.
Correct.
Yeah.
I got you. Okay. Yep, I'm following you. Oh, perfect question, because I'm eating those right now.
All right, M&Ms are small chocolate candies. The M&M website previously indicated in the United States the distribution of the colors in a bag of plain M&Ms is given in the following table. So if you reach into a bag of plain M&Ms, what is the probability of drawing a red-colored candy?
13%.
Yeah, but we're not putting them in percents, right? It's just a 0.13.
Yeah, 0.13.
So what's the probability that it's green?
0.
No,
Well,
they're
we'll have to
just-
figure that out. So,
Oh, they X that out so we can try to figure it out. I got you.
So we're just gonna add these up, right, and then subtract it from 100.
16.
I got 16, 0.16.
Yep, I got that
That's
too.
what I got.
So is not green.
84%.
4.
Yep. All right.
All right. The ACT scores of students admitted to a medium-sized public university in the western United States were taken from capix.com. The following summary statistics were calculated. Question 11. Half of the observations were less than or equal to what number?
So I think we add these up.
Do kind of run standard deviation or what?
From what I understand, you find the average, which would be the middle, right? And then, so I'm going to add them up and divide by the number that's there. Oh, no, I did that wrong. Okay, half of the observations are less than or equal to what number? I don't think I got that far in the reading. So, let's see if we can find that in the reading. I'm not seeing it. Let's see. Okay, ACT score of students.
Well, I think the answer is 22.
What was that?
I think the answer is 22.
22?
I think so. Because, well, looking at the number, I mean, 14, 18.6, 14.3, 5.
Yeah, so what I did was I put each of the values into Excel and then just put it in descending order from smallest to largest. And the middle is 22, but what I did was I took 18.6, 22, and 24 and averaged it out, and it still came out to 21.5. If rounded up, it would still come to 22. But I don't know if that would be...
Yeah, I mean, it says half of the observation. I think I'm reading too much into this question. Because half of them are less than 22. Half, I mean, there's 9 numbers. So 4 of them are less than 22. 4 of them are at above 22, and 1 of them's at 22.
Right?
Half the observations are less than or equal to.
Unless I'm reading that way too basic, I don't know.
Well, that's what I thought. That's what I thought to do at first, but then I realized that they're just giving us the mean of each number, the median. So I think would we go off the median? Because the median's going to be right in the middle, right?
Well, but it's not talking. It's the median of the ACT scores.
Yeah, exactly. So
But
The
it's asking for half of the observations, not the ACT scores. From what I'm reading into it, I could be wrong here.
that's true. I didn't. Yeah, that's true. I guess it's half of the observations, not the scores, which I find weird that they ask about that, though.
It seems like a very silly question.
Yeah. Well, I guess let's put 22 then.
Yeah, we'll try it and see what it does.
If not, we'll try something else next time.
Well, question 12 asks 25 this. Based on the information in the table above, the top 25% of the students scored above what number?
So that would be Q3, right?
I would think so.
Yeah, that's what I would go with, 27.
Yeah. Well, but I mean, and once again, I don't know if we're being too far into it, but it says based on the information in the table above, the top 25% of the students scored above what number?
Yeah,
so
so
would you put?
So yeah, so Q3 would be the break even at 27, and then so everything above 27.
Yeah.
Okay.
Okay, which of the following statements is not one of the three rules of probability? If the probability is high, then the probability is positive. If the probability is low, then the probability is negative. Because all probabilities are positive.
All right, you guys ready to submit this?
I sure am.
I'm sorry, I was reading the text. What'd you guys say as far as the last one?
Okay.
It's the one that says if the probability is high, then the probability is positive. If the probability is low, then the probability is negative.
Gotcha.
That's going to be the answer.
Gotcha. Okay.
All right, let's do this.
All righty.
Oh, we missed one.
Yeah.
The 22, question 11. That's the one
So
we
it
missed.
must be talking about.
My next guess would be 24.
24. Yeah.
Right.
That's a very poorly worded question. So either way, I'm happy with our grade, but we might as well go back and resubmit it.
Oh, yeah. I mean, if we have an opportunity to try to bust out that 100, absolutely.
All right, let's do it.
All right, I got this started again. All right, do you guys still have that up?
Yep.
Yeah, I just opened it.
Okay, what was 3?
Oh, you know what? I exited
No,
out of it.
you're fine. I got it up. It's true.
Okay, so 3's true.
4 is
was 0.
point. Yeah, 0.45. Yep, 0.55. 6 was 0.143.
Okay, just one second.
0.143.
Uh-huh.
Okay.
Question 7 is
Man.
this provides.
Strong evidence.
Yep.
Okay, number 8.
0.13. 9 is
Okay.
0.16.
Okay.
10 is 0.84.
Okay.
Number 11, we're going to guess at 24.
24, yeah.
Is that the median? Question 12 is 27.
Yeah.
And then 13 is the probability positive, probability negative.
All right, let's see how this one does. Oh, yep, it was 24.
Yep, perfect.
Nice, cool. All right, I'll go back and do mine.
Okay, do you want to get yours up and we can walk you through it, or are you good?
No, I'm good. Yeah, I'll be able to get that down.
Okay. Alrighty, well, I'll post this link since it's going to be on my YouTube page. So,
Right on.
Sounds good.
okay, guys, I'll see you Wednesday.
You got it, man. We'll
Sounds
see you
good.
then.
Thanks, guys.
Thank you.